Alrighty, everybody. Welcome. Thanks for joining me tonight. Apologize for the small delay there. My name is Brian Morrison. I'm going to go through some more of my background again in a little bit. If you joined us last week for the first entry in the course, I kind of went over a little bit of my background. We're going to be doing some more of that same stuff today. So if you're new here, if you're gonna see everything about me, I'm gonna kind of lay it all out. If you're not, then if this is the second time you're with us, then you're going to get a recap. There's some changes to go over as well to the course. Yeah, with that, we've been trying to, or I've been putting together a course on how to build APIs in Node.js, and we've got quite a list of things we're going to get to over the next couple of weeks. The original plan was to make this 4 weeks, then it went to 3 weeks, and now it's going to kind of vary. I'll get more into that anyway, but with that, I think I can pretty much get started. The only thing I wanted to throw out there before we do get started is if you do enjoy live coding, or watching people live code in general, or getting started as a developer, join my Discord group. It's Coding Live. The direct link to that is codinglive.group is the easiest way to get to it. Just put it in your browser. It'll send you an invite. You'll be on your way. But let's go ahead and get us started here. Sorry, 1 second. Alrighty, here we go. So, building APIs in Node.js. Hold on 1 second. I'm going to get rid of this guy. There we go. Make it look a little cleaner. So, why did it not change? Desktop. There we go. Apparently my OBS foo is not working out too well tonight. So yeah, let's go ahead and get into it. So a little bit about me. My name is Brian Morrison. This is one of the slides, if you were here last week, you would have seen. I worked professionally in IT since 2008. I've pretty much for the entire time held a dual role as a software and systems engineer. So I'm familiar with both sides of the house, both writing code and building the infrastructure to support it. I've been writing code for about 15 years if you do count HTML and CSS as a language. I have been writing that. I guess it's technically a language. Some people don't call it that, but I like to think it is because it requires some effort. And I'm entirely self-taught, so the only reason I include that last bullet point on there is it is possible to get into this world with being completely self-taught, especially with the rapid pace that IT changes, as long as you know the ways to kind of push yourself into the market. Some of the languages and tools that I'm familiar with, the left-hand side, are kind of the open source technologies. I also maintain an API using C# and .NET, and I'm fairly familiar with Windows and Microsoft technologies. And then kind of some of the infrastructure stuff on the right-hand side, just to give you an idea what my capabilities are. If you do want to support the work that I'm doing, the best way you can do that is to go ahead and sign up as a supporter on Patreon. I've updated the tiers actually from the last time we did this to now, so even the Supporter 1 tier does get access to the backlog of courses. So if you want to get into the base level and get access to everything that I'm building and working on, Supporter 1. Supporter 2 gets access to the source code and slide decks for everything you're going to see in these courses, as well as access to all of my research, notes, and preview of upcoming courses. And then Supporter 3 is those who are very serious about getting into the development world and making a name for themselves. In that Discord group, codinglive.group, we do also have some channels that I'm dedicated to kind of professional development, professional development, networking, and we're going to be starting a mastermind group once we kind of build up enough individuals that are going to be inside of that. Oh, wrong button. All right, so this is kind of how the course works. I'm going to go over the changes actually first because there's some details in here, and apparently I forgot to change something on this slide deck. Wednesdays at 8:30 is the new time. Last time I did this, it was Mondays at 8:30. Now it's Wednesdays. It kind of works out better for my schedule, gives me a little more time to put some of these courses together. So that's going to be the new date and time. The course is now open-ended. Originally, I had planned it to be 4 weeks. That kind of changed to 3 weeks, but we're going to kind of just work this and take it as it goes and see how things work out. Every Wednesday, we're going to be going over 1 or 2 modules, and we'll kind of take it from there and see how it goes. My Twitter is now at bmorrisondev, and in fact, everywhere I am bmorrisondev. Instagram, Twitter, you can find me on Reddit at bmorrisondev, and actually the one typo I have here is my Twitch is B Morrison Dev. So the Twitch chat will be monitored. I will not be monitoring, although I stream to Twitch, Facebook, and YouTube, I will not be monitoring chat there. I will be monitoring it solely on Twitch. So if you want to kind of get into the discussion, that's the best place to go for it. But remind you, it is twitch.tv/BrianMMO2. Post questions in the chat as you have them. I will review them and answer the questions after each module. Today we're only going over one module, so I'm basically going to be running through the course, and when we get to the end of it, I'll answer any questions. And for any updates to scheduling or what's going on with the courses, you can follow me on Twitter. Another good place to follow me is Instagram. I've started posting some live videos and stories and stuff as it relates to the Twitch channel. So either Twitter or Instagram at bmorrisondev is the best place to follow me. Modules we've completed so far. You can probably still see those videos live on or as videos on demand on Twitch. Overview of APIs and our first API. We went through kind of what APIs are, and we built out a very, very basic API that handles all the basic HTTP requests and then transfers data just in memory. Today we're going to be going over working with databases, specifically MongoDB. I've updated our code samples from Module 2 to incorporate connectivity directly into a database that's installed on my machine. So I'll be walking through the changes we've made to the code from last time and going over line by line what everything does so you have a good understanding of how to interact with database as well. And on the left-hand side, you can see our to-do column. I kind of went with a Kanban kind of design here, so we're going to be slowly moving things from the left column all the way to the right column as we complete them. Next week, we're going to be looking at integrating with other APIs. That originally was part of Module 3, but I had to push that off, so we're going to be looking at integrating with other APIs next week and most likely getting to middleware and authentication. Module 3 was actually originally testing an API. It's been kicked off to Module 6 because as I'm writing this code, it kind of makes more sense to go that direction, so I've restructured this course a little bit. Then we'll get into data validation, restructuring a project for modularity, and then our last thing, which I have linked as a bonus, we're going to get to it, is deploying the API to AWS using API Gateway, Lambda, and potentially AWS Cognito if we get around to doing that. And with that, let's get to Module 3, the beginning of our Module 3, working with databases. I got a few more slides here. We're going to be going through that's going to kind of go over what a database is and whatnot. But do forgive me, I have to take one more quick break here. Wife is out of town and the kids need things, so I will be back in one moment. I do apologize. Okay, apologize about the small delay there. We are back. So we're going to go through this the remainder of this slide deck, working with databases. Let's go ahead and get right into it. So the first question, and mind you that this course is kind of designed for those who are just coming into the development world. What is a database? For those of you who had no interaction with databases, which if you haven't worked in IT, you probably don't, and it probably sounds like a pretty scary topic. The definition I pulled from Wikipedia of a database is it is an organized collection of data generally stored and accessed electronically from a computer system. Now, it sounds like a really big explanation, but in the most simple of terms, it is a way to store data for later use. In our module from last week where we went over and we were using the data that was stored in the application itself, that's called data in memory. And data in memory is ephemeral, which means when the process is killed that is hosting the API, that data is destroyed and any changes that were made to it. So what a database does is it persists changes to data over a long period of time. So if you need to restart the API or add multiple entries to an API or multiple nodes to an API, you can do that and access a single database, and the data can be shared between multiple nodes or used later on. Here are two types of databases. There is relational and non-relational, so I'll be going through just a couple of bullet points on each one and kind of what details them and their attributes. Relational dates back to the 70s. It was one of the first kinds of databases that were ever designed. So they're pretty commonly used. In fact, much more commonly used than non-relational databases. And there's a whole lot more data and skilled professionals on them. Data is stored in a tabular format. So if you think of something like an Excel spreadsheet or Google Sheets, data inside of the database is stored in that nature. Tables within a database can relate to one another through keys, or also known as columns. So you can link tables and relate the data using those columns. Relational databases are good for highly structured data. So if you have something that a parent-child relationship that will always exist, or some nature of that, that is a good thing for a relational database. A non-relational database is relatively modern. I don't have a date range in this, but if I recall, it's been within the last 15 years that non-relational databases have really kind of taken off. I think they've been around for longer than that, but that's kind of where they started kind of gaining some traction. Data can be stored as a key value pair, or a document itself, or a graph. Graphs are primarily used for interrelated nodes and sifting through large amounts of data. Collections can be related, but relationships are less enforced. So you can either refer a collection as similar to a table within a database. You can create a reference from collection A to collection B, or you can simply store the data all as part of a single document within that collection. And finally, it is good for unstructured or semi-structured data. Here are a couple of examples of relational versus non-relational databases as far as the systems themselves. So the three I've listed out for relational are MySQL, Microsoft SQL Server, and Postgres are kind of the three most popular ones. Oracle can probably be listed on that side, but I just chose not to include it. And then there's non-relational, AWS, DynamoDB, MongoDB, Cassandra. Azure has their own flavor. I mean, there's quite a few of them to list through. I didn't want to go through an exhaustive list, but these are just a couple of examples. It is worth noting that some relational database management systems also now support unstructured columns. So say, for example, you can actually specify a JSON data type in a Postgres column and store unstructured data as part of that column. It's kind of a way that these relational database software is, I guess, kind of catching up. Okay, so that's it. We blew through it. All the slides I have, at least for the time being. So we went right into the code now, is I guess like where we're going to end up now. 1 second, throw that up there. Alrighty. So I'm going to maximize this out so you can see what we have going on here. And we're going to walk through this step by step. I'm going to minimize my terminal because we don't need that right now. I have the API working. So there are a couple additions we've made into the top of our API. What we've done is we've installed Mongoose and imported that into our app.js file. And we've also imported a user model, which is defined in this user.js file. This is an example of a Mongoose schema. So, sorry, I did not note we're gonna specifically be targeting MongoDB in our instance because it's open source, it's quick to get set up, and it's a lot of Node.js APIs use MongoDB. Although there are different libraries out there to connect with all sorts of different database software. We're using Mongoose, which is an ORM, which is an object relational mapper, to simplify the way that we access our database. So instead of making calls directly to the database, you go through an ORM, and that just simplifies and kind of structures everything that you're working on. So in our model here, what we've defined is we've imported Mongoose again here. We've imported schema, and I guess we've defined schema and referenced mongo.schema, and then we've defined our user schema. Now you can see here I have two ways that I'm actually defining the properties within there. The first is the first name, where I've simply specified it's a string. We want a string. We know we need a string, right? The second way I've defined this is using last name. You can see I could the actual properties within a schema accept a couple. You can just set the type directly, or you can actually pass in an object, and that object has a bunch of different it has a bunch of different properties that you can use to kind of further expand out on that particular property. So the first one we've defined here is type. We set that to a string, and we also set required to true. Another one that is well worth looking into is I believe it's validate or verify. I'd have to look that up actually. I believe it is validate, where you can actually specify a function that's passed into the property itself, and then anytime data is attempted to be saved into the database, it's going to pass that property through your function and make sure if it returns true, it can save it. If not, it can throw an error. So this way, you can make sure your data is well sanitized before it gets saved into the database. And then finally, we export that model. We're registering the user schema that we defined up here as the user object in Mongoose throughout the entire system. So coming back to our app.js file and moving on to line 8, we've defined a connection string. A connection string is what's used to tell Mongoose how to connect to the database. So commonly you will see MongoDB : // There's also plus SRV if you're part of a clustered system. In my setup, I'm not, so I have localhost, which could be the IP address or the fully qualified domain name of your Mongoose database server, the port, and then the final property we have here is collections. Now, if you wanted to include authentication, which in this example I'm not, you could also pass in a username and password prior to the host name of the server, and then that would be where you would specify that. Line 10, mongoose.connect is where you would pass in that connection string and tell Mongoose what database it's connecting to, or what collection it is connecting to. Line 13, those there previously. Now, all of our methods that we've defined in the last video have changed now to some degree. I've kept most of them the same, but we're going to just step through all the changes one by one. In the previous video, I had it set up so this way get had two possible ways of referencing it. The first one was just get users, or there was get users /ID. Now I removed the second example, and I've actually integrated it all into a single get request. I've changed the query parameter here to :ID ? And what that does is that tells the API it tells the API to know, hey, if there is an ID passed in, great, we can handle it. If not, we don't have to, we can ignore it as well. The query, I created an empty JavaScript object that we're going to use to pass in a query into our search for later. And then I specified here if the request.params.id, which references this query parameter here, if that exists, what we're going to do is we're going to add the property _ID and pass that in and save that into the query. Now in line 23, this is where that query comes into play. So user is the model that we defined up earlier, or the schema. .find is the particular method where you can pass in a query and return either a list of users or a single user. This is where this get request is kind of dynamic. So if an ID exists, it'll update the query and set it, hey, I just want to return a single user. If not, since this is an empty object, it's going to pass in an empty object, and Mongoose knows I just need to return everything. There's no query. So you can dual purpose this particular endpoint. And then finally, this is no different from what we did last time. Response, we want to set the status to 200 and send back the users that we found. Whether that's a single user or whether it's a collection of users, doesn't matter. It's going to pass it back as an array of users. In our post request, the only real changes that we've made so far is we passed in the request body and we've initialized a new user. And what we're going to do is we're going to pass that new user back into user.create, which is going to create an object inside of our collection in the database. You will also notice here that these particular Mongoose methods here are async await enabled, so I've gone ahead and taken care of that. So because I've set my express methods as async, I can use await to tell the API to wait for that particular operation to be done before you proceed to the next call. So we're going to wait for the user to be created, and then we're going to go ahead and set the status to 200 and respond with the user. Now put, we've forced it to accept the ID because we don't have the question mark here. So we're always going to let the query be set with the property of, whoops, clicking around too much. We're always going to have the underscore ID set for the query because we know we want a query for a particular user to update it. Updates, we're just going to reference the body, so that's we're going to pass in later. And then options, new to set to true. This basically says once the user object is updated, what I need is I need back the updated user object. If you don't specify this, what it will do is it will pass back the object before the updates have actually occurred, which can be useful in some scenarios, but in most cases when I'm building an API, I always want to make sure I can see the updates as they're being passed back. So the final thing we have set for this particular method is line 55. We want to wait for user.findOneAndUpdate. That's exactly what it says it's going to do. It's going to find a single record or a single document in the collection, and it's going to update it. I've used the three properties or three variables that we've set up here: query, updates, and options. Pass those in then exactly that same order, and that's how you would specify what user you want to find or what document in a collection you want to find, what you want to update. And now this does not need to be the entire document itself. So you can update, which I have demonstrations in Postman later, you can update just a single property, and Mongoose knows how to handle updating a single property. So you don't have to pass everything back. And then we've set our options here of new equals true. Now there are a number of options that can be specified here. Setting new to true is just the most common one that I've used. So you can go ahead and reference the Mongoose developer documentation in order to see which of those you would need in your particular implementation. And last but not least, we have the delete method. Same thing we have set up with our put method for updating a user. We want to specify an ID. We're going to set the query. Now all we need to do is find one and delete it. We don't need to update anything. We don't need to return anything new. So there is no other properties that are being passed along to this particular method. User is the model that we've passed in from earlier. Find one and delete is the method. Pass in the query just to find the user. Very straightforward and simple. And then 71 is exactly what we said earlier. Since there is nothing to send back once the user is deleted, what I've opted to do is just send back a string of OK to say that the delete was successful. And if in every single one of my methods or in every single one of my functions that I've defined here, I use console.log to log the error into the console so I can see what it does. And then I also respond back to the user, the requester, with a status of 500 to say, hey, something went wrong, and then also send back the error object. Now, generally, when you go for a production API, this is probably not a good practice. This is only being done for testing. You want to handle your errors on the back end, because sending back really granular errors back to the user as it relates to the system is not a good idea. What you'd want to do is you'd want to come up with some kind of error handler which can parse out specific bits of detail from that error and pass that back to the user. So if something went wrong that they can control, they can fix it. They can fix the request on their side, resubmit it, and hopefully get a better response back. So with that, let's go ahead and open up Postman. Okay, I can go ahead and make this full screen. We don't need to see the code anymore because I'm not going to demonstrate anything from the console. But I guess actually we could. Let's go ahead and maximize this, and we'll go back to it if we need to. So get users. The other tool actually I'm going to go ahead and bring up is Robo3T, which is a graphical user interface for a Mongoose database collection. So you can see in my collection is users that is created automatically when data is initially saved in. Let me see if I can make this a little bit bigger. It doesn't look like I can. So you'll have to squint if you're on a mobile screen. But my main point I wanted to demonstrate here is first name and last name are the two properties that we've defined earlier, as you saw in our model. And then we also have an object ID. Now, the inside of a Mongo database, the underscore ID is by default the, if you will, the primary key, the unique identifier for each particular record inside of the collection. And it is set to this object ID data type. If I right click this and I go to edit document, you will see there's an object ID and then what looks like a random string. Now, embedded inside of the string is some particular metadata that Mongo uses. I know one of the things that's embedded inside of there is the actual created date time in some kind of hashed format. So this will be inside of every single document inside of a collection you will use, and it can be used as the unique identifier for everything. So this is the ID that we're going to use throughout. These are the IDs rather that we're going to use throughout all these examples. So inside of our get users, if I go ahead and click send, I did not change anything from this from our last example, but you can see I do get that underscore ID. I get the long string as opposed to just our 1, 2, and 3 from last time, and then we get all 3 of our records that were inside of our database. If I go ahead and click create user, all I've done here is specify John Smith. In fact, I'm going to name this to, let me look at my users I have already here. John Smith exists, so we're gonna change the name to, how about Kristen? So we're gonna change it to Kristen Smith. We're gonna go ahead and send it. And now what you can see is it returned back the object that it had created based on how we had set up our method, because the underscore ID is here. So what it did is it accepted it, it created the record, and then it sent back the record that it had created with the ID attached to it. Next method is updating user. What I'm actually going to do is I'm going to copy and paste the record, the object ID from Kristen, and we're going to go ahead and paste this in here, and we're going to change the name to Morrison II because it's simple and that's my last name. So go ahead and change that, and now you can see same thing here. It went ahead and updated that particular record and then sent back Morrison II as the last name as opposed to Smith like we had specified in the previous request. If I go into my Robo3T view of the database and I refresh this, you can see now we also have Kristen Morrison II here. And using the same ID, we go ahead and pass in the ID for delete the user. We don't have to specify a particular body because all we need is the ID for the object. Send that in. It's going to send back OK. If I go back into Robo3T, refresh the view, the 4th document, the one that we had created in the previous examples, is now gone. So that demonstrates every single one of the properties that we had created inside of our code here. Okay. So that concludes our particular tutorial. It didn't work. All right, so there you go. I'll just go ahead and throw PowerPoint up there. Want to thank you for joining me tonight. I don't see any questions in the chat, so I guess I can hang out here for a second, see if anybody has any particular questions. But that does conclude our demonstration for the evening. I want to thank you for joining me tonight. If you are interested in supporting the work that I'm doing and providing all this content for free on Twitch, you can support me on patreon.brianmorrison.me is the quickest way to get to it, or follow me on Twitch, twitch.tv/bmorrisondev. I will go ahead and throw in something there. I am pretty close to getting my, I'll go ahead and flip back so you can see me talking. I'm pretty close to getting affiliate status with Twitch, which means that I can start actually generating a little bit of revenue and income from that, and that's going to just help help me be able to create more of this content. So the more viewers I can get, I've gotten every single one of those line items down, but the more viewers I can get, the higher I can get my average viewer rating up to 3, the better off I'm going to be. So if you can do me a favor, follow me, share me out with any friends, family, anyone who you think would be interested in this content, that I would much appreciate that. Been a couple minutes here. I'm not seeing any questions in the chat. I'll wait here another minute. How's everybody doing tonight? How was the day? Anything fun or interesting happen? Just want to say hey. Going once, going twice, going forth. I don't know what a force. May the force be with you, I guess, maybe. All right, I'm going to go ahead and next to stream then. Thanks again for joining me, and everybody have a great evening. Bye-bye.